Welcome to Science Access. In today's class, we're going to be talking about the coordinate or dative covalent bond. Remember, in my previous class, we talked about the electrovalent or ionic bond. We've talked about the ordinary covalent bond. So we'll be discussing the dative covalent bond. Why do atoms carry out chemical reaction? Why do they combine? It's simple. Because they want to attain what? Stability. Just the way if you get hungry, you take in food to get satisfied. They want to attain stability. So note this. Now we've been illustrating the coordinate covalent bond with these reactions. Note this. The difference between the ordinary covalent bond and the coordinate covalent or dative bonding is that in this coordinate or dative covalent bond, the electron that they are sharing is contributed by just one of the atom, not both parties contributing it, no. But in ordinary covalent bond, you realize that the electron that they are sharing is contributed by both atoms, but in dative, it is contributed by one of the atoms. Now, let's take a look at this example. This is ammonia and this is hydrogen ion. How do they combine to form the ammonium ion? That's what we are going to discuss. But before we do that, note this bond. This is nitrogen, this is hydrogen, so we'll use N to represent this. This is H, and this is H. Now, the bond between nitrogen and the three atoms of hydrogen is a covalent bond, ordinary covalent bond, not coordinate covalent bond. The reason is simple. Look at the electron that they are sharing. It's actually contributed. One, this is the electron from the hydrogen, this is the electron from the nitrogen. You can see the nitrogen electron I use star but to represent it, while the electron of the hydrogen I use star, that is cycle, to represent. So the electron is contributed by both, the electron is contributed by both, and the electron is contributed by both. But in this case, there's a lone pair of electron. This is a pair of electron that is not, it's called lone pair. It's not actually shared. So note, there's a lone pair of electron. Now, this is hydrogen atom. Have just one proton, right? So this is hydrogen atom. But this hydrogen atom have lost the electron in it. So you don't call it atom anymore. You call it hydrogen ion. So once it loses the electron, it becomes an ion. So we can now refer to this as hydrogen ion. The reason why I'm adding the positive sign here is because the number of protons in the nucleus is just one positive sign, while the number of electrons is one negative sign. But this atom have lost the negative sign, so the positive sign will now be placed there. So it has just one proton, which is positive, as the reason here. Now, this atom can decide. Remember, the first shell take a maximum of 2 electrons, right? So this atom always desire to have this first shell filled with electron, maximum of 2, and sees this lone pair of electron present in here. So what will the atom do? It's simple. This atom here will now come to this place, and this is 2 atoms. Remember, there is positive sign here. So these 2 atoms is not the atom of the hydrogen. It is actually contributed by the nitrogen alone, but both atoms are actually sharing it. So this kind of sharing in which the electron is actually contributed by one of the atoms is called what? The coordinate or dative covalent bond. Please note that. Let's illustrate it using another example. Now, the second example here is actually the reaction between water and hydrogen ions to form the hydrozonium ion. All right. Now, you can see the water molecule here. Take a look at the oxygen. This is the oxygen, and this is the hydrogen. Now, the oxygen has definitely 8 protons and 8 electrons. So we put the 2 in the first shell. The second shell will take 6. But there's a desire in this oxygen to have 8, right? So that's the reason why it combined with the hydrogen. So this is a purely covalent bond, because the electrons that are shared between this hydrogen and this oxygen is contributed by both. This is contributed by the oxygen, and this is contributed by the hydrogen. This is contributed by the hydrogen, and this is contributed by the oxygen. So, but this atom have 2 lone pair of electrons. This is one lone pair, and this is another lone pair. So just like in the first example, this is hydrogen ions that are actually lost a particular, these hydrogen atoms that have lost a particular electron to form hydrogen ion. So in this case, this one can eventually attach to this. That's what we have here. Always put your positive sign. That's what we have here, because this bond between this and this, the electron here, they are contributed by just the oxygen atom. So this is another example of coordinate or dative covalent bond. It's a very simple kind of bond. In my next class, I'll be discussing other type of bond. Thank you for watching.